Welcome, everybody, to another meeting of the Triangle SQL Server Users Group's Advanced DBA Group. This one tonight is remote only, so thanks to everybody catching us on the stream. As I've been announcing for the last few of these, SQL Saturday Raleigh is coming up April 18th at Wake Tech RTP, just in the middle of town. And for now, the event is still definitely on. We will keep you up to date. North Carolina did officially declare a state of emergency today, but I'm going to keep abreast of current events and we'll hopefully be able to put this on with no interruptions or any sort of degradation of service. So in the meantime, sign up at sqlsaturday.com/981. We're going to get the schedule out for that very soon, so you'll get to see exactly who's speaking on which topics. Admission, as always, is free, $15 charge for lunch if you're so inclined. And now we're going to hand over to the speaker of the night. Pop over here to the remote stream, and we have David Klee on the line.
Hello, everybody.
Yeah, you're not going to get much response directly from people, but I will
Yeah,
pass along responses as I see them in chat.
perfect. Okay, let me know when you can see my screen okay here.
So I can see it just fine. How about anybody in the audience? Oh, we got a hello back.
Sweet.
So there's about a 20 to 30-second delay back in stuff from people. So yes, you're getting yeses from people that we can see your screen, so you're good to go.
Perfect. Well, thanks everybody for making the time after work or really wherever you're at today. Hopefully, everybody's staying in, staying put, staying safe. If there are any questions at all, feel free, get them in the chat window. I will not leave until all the questions are answered. I don't have much of a life, so this is what I enjoy doing. This is all things SQL in the Microsoft Cloud. My name is David Klee. I am fortunate enough to be both a Microsoft Data Platform MVP and a VMware vExpert. I've got a quirky sense of humor, if you haven't noticed by the screen here. I'm the founder, and I call myself the Chief Technical Exorcist of Heraflux Technologies. I have a lot of fun doing a lot of infrastructure, virtualization, cloud, performance tuning, business continuity planning, a lot of architectural work, a lot of health and efficiency and capacity management. And quite frankly, I have a lot of fun with those. Contact info is up on the screen. Again, feel free to reach out if you have any questions. There's no marketing attached to this. I don't do that. I don't believe in it. I have a lot of fun fixing problems, and hopefully you'll be able to learn something tonight. Okay. First of all, there's no such thing as the cloud. Sorry to disappoint everybody, but realistically, all the cloud really is virtualization in somebody else's data center with some really, really, really good automation in front of it. As a result, there's a lot of things that stay the same. There are a lot of things that are similar, but because of the automation and the power of a lot of these services, there's a lot of improvements that we can make with the cloud. Now, I know the title. This is all things Microsoft, all things SQL in the Microsoft Cloud. Um, there are three biggest cloud players out there. There's a Microsoft Azure platform, there's Amazon Web Services, and Google Cloud Platform. Um, I personally, get rid of the company logo. I land on Azure for all of my stuff, and partly because, well, they wrote the code that we run, database engine, operating system, things like that. It's just a good, solid platform. I don't have anything at all against the other players out there. I really don't. And I use Amazon for a couple of things for backups, but my production environment is all on Azure. And quite frankly, just ignoring white papers and things like that, I have found that for the way I use it, it's a little bit quicker, a little bit more cost effective, and a little bit easier to use. So I like Azure, not because I'm a Microsoftie or anything like that. I like it. When we take a look at SQL Server, traditionally, this is a boxed product. There's the database engine itself. You've got the ancillary components. There's integration services, reporting services, analysis services. Microsoft launched their relational database as a service engine on the Azure platform all the way back in 2010. That's 10 years ago now. Gets really interesting because of the shift in Microsoft. They're starting to produce their platform cloud first and then roll it up and give you a box product periodically. It's really interesting. Because of the changes with the cloud and the way things are shifting on prem, we now need to figure out what's actually better for us. What are our options out in the cloud versus on prem? And I'm not here to tell you that cloud is the right and only solution for you. Cloud is a really good option when it's the right use case. And don't let anybody fool you. Cloud's got a lot of really good use cases, but it is not the only solution. So if you're looking at the cloud to compare to on-prem, you've got IaaS or infrastructure as a service. You've got PaaS or platform as a service. In this case, it might be more database as a service, instance level, things like that, or other acronyms that don't make any sense. Um, what do we actually need? And this is one of the hardest pieces. Picking the right service in the cloud is arguably one of the more challenging, one of the more tough, really choices we have to make. Because with some of these, it's not the easiest to get data in or out of them. And as a result, if we realize mid-flight, in the middle of a migration cycle, that this isn't the right choice, you got to undo a bunch of work to get the data back out and get it into something else. So we're going to start with the database as a service. On the Azure platform, it's the Azure SQL Database. It's literally just a database. It is fully compatible all the way up to the latest version of SQL Server and then some. What you'll find is that when Microsoft gets kind of close to some of these major release points for the box product, you may actually see some new features slip into the database as a service platform on Azure. And that's because that's where they're releasing this stuff first, which is really cool. There's a ton of good use cases for this. If you just need to spin up a quick database for just something small, it's great. Throw it out there, it just works. Rapid application development, smaller databases, POCs or pilots for some bigger things that you're working on, DevOps to just rapidly get things rolling. Or, if you've got an environment that's got a lot of single tenant databases that can grow pretty darn large, it's a really good way to scale this thing out. It's a solid platform. Now, pros, how many of you have spent hours and hours in the middle of the night actually dealing with SQL Server patching? Well, you got to apply cumulative updates, service packs for the old versions of them. It's just a challenge. I'm personally done with patching this stuff because so I'm 40 and I've been patching these machines for 27 years. I'm done with middle of the night patching. As much as I hate to admit it, I'm done. In this case, I don't have an instance to manage. I don't have an operating system to worry about. They take care of this stuff for you, which is great because am I in the data center business? No. Do I just want a database to work so I can use it? Absolutely. If I want HA and DR options, it's great. You just basically pick the scale of the platform, pick the type of platform and the criticality tier, be it standard or business critical, and they take care of your HA options for you. You get what you get. DR, if you want DR, you say, I want DR, pick on a map, hit replicate, and go. All you got to worry about is the associated charge. Now, with any of the platforms, on prem, cloud, whatever, there's pros, there's always cons. And I'm never going to sugarcoat this stuff for you. Cons, it is a single database. If your application architecture is such where you've got, let's say, two databases or things like SharePoint that can dynamically create databases underneath for you, that's not going to work. It's just a database. So as a result, no cross database calls, you don't get a SQL agent. Now, it seems like it's a big deal. It's really not. A lot of times, all we need to do is just trigger certain commands, things to run. So instead of using the SQL agent, you use a little bit of PowerShell, a little bit of elbow grease, go run these with Azure Runbooks, and the end result is exactly the same. So it seems like it's a big deal. It's not as big of a deal as it normally should be. code adjustments get interesting. I've seen a number of applications that are using third party or excuse me, three-part naming just to get to one database. Occasionally, they'll end up using just antique code constructs or linked servers or a lot of these other components that are not there. And you may have to go adjust this stuff. It seems like it's a big deal. Most of the time, it's not that bad. It really isn't. The biggest challenge with this is the migration strategy. Currently, today, there's not a backup and restore option to get data into an Azure SQL database. So what you have to do, you could either pump data in, recreate the schema, use SSIS, use Azure Data Services to basically as migration services to migrate data in and out. It gets interesting. You have to worry about keeping things in sync. The services that they've got are pretty good, but if you don't have primary keys or clustered indexes on some of your databases already, you may have to turn on CDC. There's some nuances with it. But for net new things where you don't have to worry about that kind of stuff with pumping just billions of records in, it's solid. Even for the stuff that does require you pumping data in, there are options. It's not perfect, but there are definitely options. Now, for the general database tiers, the general purpose, 50 to 20,000 IOPS, they claim 2 to 10 millisecond latency. There's a hyperscale option, which allows you to essentially let this thing shard underneath, which works really well. 500 all the way up to 204,000 IOPS, they claim 1 to 10 millisecond latency. That's pretty cool. You get up to 4 replicas, so you can actually start to scale this thing out and let this thing really flex its muscles. For the truly business critical stuff, they've got a business critical tier, same thing, 500 to 200,000 IOPS. It does allow read scale out. They do give you greater availability in the number of nines underneath this thing. In my experience, they generally beat their stated SLAs anyway with any of these. But if you're running production business critical workloads, I would definitely opt for the extra cost on the business critical tier. It is worth it. For all of these, you get up to 80 virtual cores worth of compute power. You got to pay for it. But quite frankly, if you have a SQL server that big, you know what you're getting into. If you have demonstrated need that you need that amount of horsepower, then it's a good option. If you've got a need beyond this, we need to talk because we need to talk about a scale up versus scale out strategy. A lot of times when you hit that point, there is a high likelihood that you're running into the limits of what the platform itself can do, just in terms of on-prem servers, let alone cloud-based platforms. So the application architecture really should be revisited at that point to see if you need to adjust it. You basically pick the scale and then you pick the maximum data size for this. Now, if you deployed an Azure SQL Database tier a long time ago, there was a DTU model. There still is, but I call it kind of legacy at this point. But one, what the heck is a DTU? It's a database throughput unit. That doesn't make a lot of sense until you start fiddling with it to figure out the scalability of a DTU versus cores and RAM. There's two models, standard and premium. Generally speaking, for anything net new, you want to go with the vCore model. It's easier to manage. It's easier to really comprehend because this is what we're used to. That said, it's not that bad if you're stuck on it right now. And I can actually show you. Um, so if you look, this right here, and I'll zoom in here in a second, this is an Azure SQL database. And this is a CMS database that we built out. It's pretty basic, nothing fancy on there. But this is underneath our consulting management system. Just something small I put together. It gives me the ability to take a look at clients and employees and uh, you know invoicing periods and tasks and just basic stuff around time tracking. Nothing fancy. You notice I don't have a SQL agent in here. I don't have database mail. I don't have to worry about index optimization. It is fully featured from T-SQL standpoint. I mean, I've got temporal tables in here. There's just a lot of really good stuff that you can use. And from a performance standpoint, you'll chuckle, but when I first put this together, I put this on the $5 a month tier on Azure because, quite frankly, I wanted to see how bad it was actually going to run. It works so well, I just left it there. This is literally the 2 gig basic tier. There's nothing fancy about it, and it works well enough that I don't need anything more. This is a perfect example of what an Azure SQL database can actually give you. If I just need a database and I don't either care or have the time to deal with all the routine maintenance underneath, it just works. It literally just works.
So we have a question from chat.
Yeah.
If you have any experience using Azure Data Sync to move or copy data.
Yes. Um, the question is, what do you want to know with it? Because it does work really well. Essentially, for those of you that have never played with it before, Azure Data Sync is a way to allow the cloud to remotely connect in to one of your SQL servers and either scan the transaction log or it basically simulates replication. And it's basically a really good way to recreate a schema in the cloud and then pump data from your database to the cloud database and keep it in sync until you're ready to cut over. It's pretty darn handy.
Follow up is if you have any way of monitoring or reporting data errors that you've seen with Azure Data Sync.
That is a really good question. Quite honestly, no. I don't have a good way to do that. What I've done personally is I'll actually write something that'll do a real quick compare table by table of the data when I'm ready to do a cutover, and just a little bit of C sharp that can connect to the two, compare the contents of the tables, and call it good. It's not elegant at all.
It
Um,
works.
it works. I don't like things that just work. I want things that work well, and I don't have a good thing that works well for that one, unfortunately.
Hmm. One more question. Do you have the SLA for the basic tier, that $5 a month database? And what do we know about SLA validation?
That is a really good question. So let's see. Azure. I want to say the number nines on the $5 a month tier is 4 nines. Let's see, but don't quote me on that. Let me look this up real quick. General availability database cloud as a service. Um, what I'll need to do, I need to dig this up unless I can find it here in the next 10 seconds. Worry about scalability and availability. Blah, blah, blah. SLA, don't care about your buzzwords, service tier availability, zone redundant. Okay, I need to look into that and I will
Yeah,
get
it looks like it is
that.
4 nines.
Okay. So 4 nines translates to a decent amount of an outage per year. I can tell you that with this particular system, I have yet to actually see an outage that lasted more than about 20 seconds. That said, I've not seen many of them at all. So I'm confident that this particular database that I use here has exceeded those 4 nines by a considerable margin. Um, how much? I'm not sure. I'm not honestly tracking it, but it has never been a problem where this thing wasn't readily available when I needed it, and I do tend to work around the clock.
All right, thank you.
Cool. Okay. Next one. There we go. Okay. New on Azure SQL Database. They are, they're going serverless with all the cool kids, right? So there is a serverless option, and essentially what it does is it will put your database to sleep. You define the threshold. There's this thing they call an auto pause delay. You define it by days, hours, and/or minutes. By doing it this way, if there's no connection or traffic in, it'll put the thing to sleep. You get charged for the storage still, but not the compute. So for these really big machines that are idle, let's say it's a Monday to Friday, 9 to 5 kind of database, that's fantastic. Give it a 1 hour threshold, let this thing go to sleep, let it sleep all weekend. That compute cost is considerable. This can save you hundreds or thousands of dollars a month per server just by turning this thing on. You do need to be on the Gen 5 platform. It is worth exploring, in my opinion. It's pretty powerful. That's if your database workloads actually allow for this. And I would claim that it works well because it doesn't take long for this thing to wake up when you start to ping things for normal day-to-day traffic. There are limits on there. Instead of the 80 core max, right now it's at 16 virtual core, and instead of 4 terabyte database, you have a max of 1.5 terabyte. I would claim that's still enough for a lot of workloads out there. So it's worth exploring anyway to see if this would actually fit your workloads. Now, we talked about the database migrations. You just can't do a backup and restore into this. Like I said before, you can recreate the schema, use SSIS to pump data in. There's a backpack import export kind of thing. If you're just doing the schema, backpacks work for that. If you're doing the data, backpacks work. Azure Database Migration Service works really, really well. You do have to worry about things like primary keys, and if there is not one, well, there should be, but if there isn't, then CDC will help you there. Um, the biggest thing for me, this is a loaded statement, but how many of you, by show of thought, how many of you dread DR drills? It should be everybody. DR in the cloud is absolutely incredible. In this case, my primary site, East Coast. I want DR. Okay, I click on a map, I hit OK. Boom, you got DR. That's amazing. That is absolutely amazing. You try to do that on-prem, and there's absolutely no way, unless it's one of the largest, most highly orchestrated companies in the world. There's no way. For me, for the cloud, the DR side of it is literally one of the biggest possible benefits that you can get out of it. Yeah, you got to pay for the platform, that sort of thing, but it does really work well. Okay. Any other questions on databases as a service?
None so far.
Okay. Can you hear me okay? I just hit mute and the light didn't come on to cough there.
Yeah, I heard you cough, but
Okay.
we can hear you just fine.
Okay, cool. My mute button doesn't work. This is awesome.
At least you know it now instead of later.
Exactly. That's why I checked. Cool. Okay. So let's say your workload doesn't quite fit with an Azure SQL database. So maybe you've got two databases or four or 10 and they all talk to each other. Or maybe I've got certain things that I actually need the agent for, or database mail, or any other number of components that you actually need more of the SQL Server for. Well, Azure has SQL Managed Instance. And it's 99.9% a SQL server just without the operating system, which is awesome. That's quite frankly more than what most people are actually using anyway. It's almost a full SQL server. There's a handful of gotchas with it. But yeah, multiple databases. A lot of the stuff is just not available in the SQL Server layer. Link servers, cross database calls, you name it, it's just there. You don't get extended event or no, sorry. If you need extended events, if you need the service broker, which I'm a big fan of, if you need CDC or even transactional replication, those are things that are just not available in the core SQL database engine. They are available in the managed instance. SQL agent's a big one. It's not entirely complete. You don't have things like XP Command Shell because, well, you don't have an operating system to worry about, but they take care of the Windows layer patching. They take care of that automation and orchestration. So if this is a better means for you, use it. It's awesome. Yep, more stuff in there. Query store, cross database queries, CLR assemblies, all that kind of jazz. Okay, service tiers. There's a general purpose service tier. Works really, really well. I believe that is 4.5 nines, if not 5 nines, I forget. Um, the high availability is through Azure Blob with the Service Fabric tying everything together. It works well. In the event that there is a hiccup and that thing goes down, it takes a little bit longer for it to come up. Um, that's okay for most workloads. Now, if this thing is really latency sensitive, Go with the business critical tier. It does cost a little bit more, but it's actually a synchronous availability group underneath. So bottom line, you get, real quick failover there. You do have the option for read-only replicas for your read-only workloads. It does work really well. Now, pros, again, like I said, it's almost a full SQL Server instance. Um, you can do a database restore from Azure Blob, and that goes a long way. So, back it up to a URL or back it up locally, copy it up there, issue the command to just simply do the restore from Azure Blob. Life is good. Like I said, you got the SQL agent, HA and DR, those become a point and click exercise again. HA means either general tier or business critical. DR, you click on the map where you want to replicate to, hit OK to accept the charges, hit OK, you're done. It just works. This does give you a faster possible migration time when you're looking to get a database into the cloud quickly. You can do a backup, a full backup one morning, do a differential later that evening, pump in the last transaction log, do the restore. You can actually do a cutover time very quickly. Or things like Azure Migration Service will run just as well here as it will with the other. Cons, if you need the full flexibility of an operating system underneath, which, I'm certain we've all got applications that have a lot of these legacy constructs in there. Well, you just don't get it here. Some external dependencies don't work. Uh, if you need custom HA or DR options or need the ability to put backup somewhere else, you have to deal with that. But again, it's not that big of a deal. So I'm pretty happy with the managed instance, all things considered. You can do the backup and restore via Azure Blob. You can do it the other way too. So, recreate the schema, SSIS, do a backpack import export. If the database is fairly small, you can use the Azure Database Migration Service again. Um, you know, it's more flexible, but most of the time it's just business as usual. Now, again, limitations, it's a database engine plus the agent, no SSRS, no SSAS. Integration services is possible, but you do need to recreate and reconstruct your integration processes to use the Azure Data Fabric in order to help wire things together. Again, it's not that big of a deal, but if you don't have a lot of time or or energy, or if you've got a bazillion SSIS packages, that might be prohibitive. In that case, I would look at things like one of the SSIS automation frameworks, but it can work. Agent limitations, things like XP command shell, firing external commands, some of those things are a little more limited, but again, do you really need them? If you do, and you can't change that process, maybe the managed instance isn't right for you. But most of the time, these things are pretty straightforward to work through. Manual backups are copy only. This thing takes care of the backups for you. I'm okay with that. I'm tired of babysitting this stuff. If you need a manual backup, you got the option and it's straightforward. There is a 4 virtual core minimum. This does go up to an 80 V core max. I'm okay with this. It used to be an 8 core minimum, and that got kind of expensive. To go with a 4 core minimum makes it a lot more reasonable. It's still honestly, a little bit more expensive than on-prem when you weigh everything up, but it's getting better. It's getting better every day because a lot of these things on-prem are starting to cost more and more and more. Cloud, it's a race to zero in some areas, so it's either flat or it's pretty darn close at this point. You can also use the Azure Hybrid License benefit to take licenses that you've already purchased on-prem, transition them out there. You can also do reserved instances, save a small amount of money there. It's pretty powerful. Storage, in this case, you can go up to, I believe, business or the general purpose. You can do 8 TB of storage. With business critical, you can go up to 4, but it's fast. I love the fact that it's either fast or super fast. I love the quantification of that. I'm guessing it's local SATA-based SSDs versus NVMe, but I don't know. It's fast enough. I've never really had a problem with it. Okay. Managed instance limitations get interesting. You've got 100 databases max, and in part because it's an availability group, Microsoft has a soft limit on worker threads at about 100 databases, so they've put a hard cap there. I claim most of the time it's not that big of a deal. You don't get polybase, you don't have access to server level functionality, and for that one, I'm actually fine with that unless you absolutely need it. Application vendor support is one of the interesting areas. Will the vendor fail to certify or support your application if you're running this thing on a managed instance? And that is something that is definitely worth inquiring about. Because quite frankly, you don't need to put your business at risk if you have an actual bug that you hit in an app and you call them and they see that and they freak out and they don't want to help you. So clarify with them. A lot of times they may say no, but it's only because they haven't tested it. Offer to work with them. Say, hey, you know, I'll let you look at some testing that I'm doing as long as you'll in writing certify that this isn't going to be a problem. Because I mean, it's just a SQL server. Most of the time, it works just fine. Don't let them scare you. An interesting thing, though, you can back up into this, but you will have a real issue going to restore from it. This thing is running a newer version of SQL Server than what you've got on-prem. So it's not going to allow you to back up from it and restore that database on a normal version of SQL Server. It just doesn't work. And that can be a challenge. I claim it's not an intentional bit of vendor lock-in. It's just cloud first development. So if you want to pull it off of here, you'll end up needing to use some other migration tool, which we've already talked through, to get that data out of there and put it somewhere else. So be careful with this, but it's a known thing. It's not that big of a deal. Any questions on managed instance? And I would have one deployed, but went to go do it over the weekend, had a hiccup there, and it didn't deploy in time.
I'll give chat a moment to see if there are any questions there. I was a little saddened when you said no polybase.
I know. Polybase is awesome for what it does.
Oh yeah,
Yeah, and that said, I don't have a lot of direct hands-on exposure to it, but the stuff that I've played with and seen on it, it's fantastic.
yeah. As long as you don't need immediate response in queries.
Yeah,
Sounds really bad, but then you realize, wait, I have a lot of batch queries. They just run.
yeah. Most of the time, it's warehousing or integration, things like that can run asynchronously in the middle of the night. I don't care. Just let me get there easily.
Yeah. So we do have a question. For
Cool.
managed instances, I think it's for managed instances. Are all editions of SQL Server supported for this? Like, could I have a standard edition managed instance?
That is a good question. You can't really think of it as standard in enterprise anymore. It's more general purpose and business critical. Microsoft has made some major changes with their development strategy so that the development and basically T-SQL feature set are going to be identical. So you don't really have to worry about that too much anymore. It's now scale and availability that they really want you to go after. So that's where the general purpose tier, same developer experience as the business critical tier, but it's scale and speed and availability.
Okay, and are you able to switch from Azure SQL DB, as in the single database model, to a managed instance?
Right now, they don't have a way to simply flip a switch and move a database upwards. You would have to deploy a new managed instance and then get the data into it.
Cool. Those were the questions for now.
Okay. Yeah. Now that said, we got the MVP Summit coming up next week. I'm actually going to grill them pretty hard to see if they have a different answer for me on that. Who knows? But no matter what, I'm going to tell them they need to get there because that would be a really cool thing for people to do.
Oh,
I know I need
absolutely.
to.
One more question. How would reporting services tie into this?
That's a good question. You would have to deploy a reporting services instance on a VM somewhere and make sure it's licensed appropriately. And then you could put a reporting services database on a managed instance, but it would be connecting remotely to do everything that it needs. So you wouldn't be able to install it natively.
Great, thank you.
Yeah, I wish they had reporting services as a service, but right now they don't. Okay, so now let's say we've got some convoluted crazy code or any other number of reasons why a VM with the operating system attached is something we would absolutely need. And there are definite use cases for this. We may have legacy code, there may be external services that we need to connect to. Going with a VM, so Windows or Linux, plus the SQL Server instance, it gives you full flexibility. You have the fastest possible, ability or fastest possible migration time. You have the most ability to customize this thing to what you need. I'm not saying this is a good or a bad thing. I'm just saying it's an option where if you need it, you've got it. The cons, you patch it, you manage it. You have to deal with the availability of the SQL Server layer, like you normally would. DR becomes more of a where do I want to replicate this data to, or replicate the VM to. You still have to manage backups from a SQL Server perspective. But again, if you've got very unique or specialized needs, this is a good option. Is it my first choice? Probably not, because again, I'm just tired of patching Windows. But at the same time, there are many use cases for this thing. So at the end of the day, what platform actually works best for you? So you don't have to standardize on any one of these things. There's a lot of different use cases out there. There's a bunch of different platform choices. So, database as a service, instance as a service, VM, or on-prem. We have specific workloads where they've got SQL servers that are too big for the cloud or that they're not ready to go yet or that it's cheaper on-prem and they have a really good investment already on-prem or any number of reasons. There's use cases for all of this stuff. So I claim it's kind of like a choose your own adventure game where you pick what works best. So the hard part is understanding your needs and what's available up front so that you pick the correct path because rolling out of one of these into another becomes a bigger challenge. Bottom line, though, you as a DBA have to work with your infrastructure administrators to make sure that these components are set up the way you need it. They may have to help you on scale, but don't let them dictate this stuff for you. You have to be the one to say, this can or will not work on these other tiers. We have to be, managed instance, or I don't want to deal with Windows. This thing will work great from a database as a service standpoint. It's up to you to define this. They don't know SQL Server, and that's okay. Once you pick the platform, now you got to go pick the scale. And that's the interesting part. I might want a Ferrari to go do normal daily driving in. I'm half Italian. I love that kind of stuff. But quite frankly, if I'm just going to get groceries once a week, do I need a Ferrari? I want one. But realistically, I need something like a minivan that can haul a lot of stuff. What do you need in order to perform your workload? This is the act of right sizing, and this is an area that will separate you from other DBAs. Most DBAs think techie, nerdy stuff. Quite frankly, cloud costs, and it's an entire shift in the financial model around these things. Historically, these companies will pay for servers, virtualizations, licensing, SQL Server licensing. They'll pay for it up front, pay annual maintenance on it, and call it good. The cloud claims that you pay by consumption. That's not always true. And for most of the things that we do with SQL Server, that is not true. It is actually pay by allocation. So what we need to do is figure out how much you actually need. In this particular example here, a D13 V2, 8 core, 56 gigs of RAM with SQL Server enterprise licensing included, it's $3,000 a month. If you turn it on and forget about this thing and no activity is happening at all on here, you're still paying $3,000 a month. That's not cool. That is expensive stuff. So if you can justify allocating less and using actually what you consume and using what you allocate, you not only are golden in the eyes of the CIO, but you just got the ear of the CFO. And that makes you stand out in a really good way. Because at the end of the year, when you're doing your annual review and you can say, I saved you this much money by downsizing our SQL Server licensing footprint and our spend, So can I get 20% of that as a bonus and go to the PASS Summit at the end of the year? Hopefully they're going to say yes because you just saved them a lot of cash. So the question is, how much do you actually need? And this is an interesting area. I'm a DBA. I've been a career DBA for a long, long time. I want all the CPU and all the RAM, and that's just all there is to it. We have to worry about this. There's CPU, there's memory, there's storage space, and storage speed. These are the major areas that we have to handle. You have more flexibility in the selection of these as you approach the virtual machine layer. And that's just a proven fact. You have to define the platform, and it's up to you to tell the systems folks how much of these resources you actually need. So I ask a loaded question. Do you have a resource consumption baseline objectively showing what your SQL servers are actually consuming related to all of these consumables? And most organizations don't. And this is what's really scary. Even other monitoring tools out there, they're low granularity averages. An example of this, customer called up a while back. I got 32 CPUs. It's slow as dirt. We're throwing cores at this thing. It's got to be the network because we're only at 6% CPU busy. They claimed it was the network. I went and pulled up Task Manager of all things. Somebody had changed the CPU affinity inside SQL Server to only use 2 cores, and they had 30 other CPUs that were functionally idle. There's a problem there. The granularity just wasn't good enough. So at the end of the day, what do we do to actually get the information that we actually need? Bottom line, let's collect some raw data. If you've got third-party tools like SQL Sentry or SolarWinds DPA or Idera, they're good tools. You may have to go mine the information in order to see what's really going on, but you can do this. If you don't have any of these fancy tools, or if you just want the raw data, go collect Windows Perfmon information. You've got it on your SQL servers already. It's free. There's no additional charge. There is a PDF out here, out at our URL shortened link. No contact info required. It just links to a document, and all it is a document that just says how we like to see Perfmon set up. We set it up to collect at a 30-second interval. It doesn't slow anything down. We've measured it at extremely low resource consumption on just 1 core. So it's nice and quiet. It cycles the files every night. It cleans up after itself, and it works. Now, if you wanted to, you could export this to a CSV by using the relog command. And then you can, pull it up with Excel, do whatever you want with it. Third-party tools work well. Now, everybody on the internet says, go collect Perfmon information. Nobody ever says what to do with it. Well, about a year ago now, we snuck something out onto the internet, forgot to tell everybody. We have a PowerShell script that allows you to import these Perfmon files directly into a SQL server. And now these are in a relational database platform that gives me the raw data. A little bit of T-SQL, Power BI, Excel, whatever you want to use to get to this raw data, you now have the ability to actually see all these different metrics. So check this one out. This is from a customer, raw SQL Server performance information by core. 8 cores allocated right now. You can see starting at midnight, or actually starting, let's just start here at 6 p.m. They kicked off some batch process that had one CPU core that was really, really active. It finished up by about 12:30 at night. They had another batch process kick on at 2 a.m. There was one of the CPUs that was a lot more active than the other. Another process ran at 5:30 in the morning. From that point, people started logging on about 7. You can actually see a small gap here when people went to lunch. This razor tooth section, that's basically a big process they ran on the hour. And then everybody got done about 4. Productivity dropped way off by 5 when everybody was going home, and repeat. This gives you a really good sense of what's actually going on at that organization with the way they use this database engine day in and day out. So if you take a look at this, and I want to size this thing for the cloud, they got 8 cores on here right now. The scale here, this line right here is 40%. Even the most active CPU core on here is barely even touching 50% at peak. Do they need all 8 cores? No. Give me 2 numbers. There's an aggressive conservation number, and then there's a conservative number. If I want to be aggressive and right size this thing, I would actually start my testing at just 4 cores. You need to have any number of queries or scripts or utilities or anything that will help you go validate that downsizing this thing is not going to negatively impact the business. But most of the time, you'd be really surprised in that these performance details, where if I'm more aggressively using it, but I'm not pinching it any, you'll maintain performance. You just cut the licensed SQL Server footprint in half. If you're in the cloud, that's half the money right there, just gone. You save that immediately. And even when things are active, it's only active on 1 core here. So that core will still be active. The others may double. But I mean, that's what, going from 20 something to, low 40s, 50% maybe. That's fine. So if you look at a percentile spread, you can also go see just how active this thing really is over the time slices of the day. Not a lot of variance in here. When it's active, still barely breaks 50%. I'm fine with that. I would start my testing between 4 and 6 cores. So it's up to you. Is this a Monday to Friday machine, or is it a 24/7 machine? Do we have maintenance windows outside of normal business hours where if that's the busiest point in your day and that thing is crushing the machine for 20 minutes while index maintenance runs, what if it takes 30 instead of 20 minutes? Does that hurt anything? Sometimes it does, sometimes it doesn't. That other example, no more than 50% at the absolute max, no more than 40% at a 95th percentile across a given day. I claim that aggressively we could get it in 4 cores and start our testing. Conservatively, 6 cores. That's pretty handy. 2 CPUs you're not paying for, 25% price reduction quickly. Chances are we can go with the 4 on there, and that's 50% less CPU. You still got the storage to account for. But that's about a 45% net savings in price right there. And you can see just how big of a difference that actually makes. You know, $400 a month, 12 months. There's your past summit right there. Okay, any questions up to now?
Um, Giving folks a moment. Nothing in the latest section while you've been talking.
Okay.
So if there are questions, I'll probably just cut you off in the middle of this upcoming segment.
Works for me. Cool. Okay. Now, depending on the platform that you're on, or depending on your workload, you may have some very specific requirements for CPUs. I'm kind of a nerd like that. I like handpicking CPUs based on the workload. In the cloud, you may not have quite as many options. Some of these services allow the CPU core count. Some of the times, the different cloud providers will actually give you the exact make and model, the chips that are underneath a given service. Azure is really good with that. They'll actually give you the exact chips. Other services, it is a little more abstract, like a database DTU, database throughput unit. They're a little awkward sometimes, but most of the time it's vCores, VRAM, life is good. Example the DTU there. What the heck is a DTU? It's up to you to have that mechanism in order to go test and scale this thing and just see how well it performs compared to what you've currently got right now, which are core-based models. Now, memory is a very interesting construct. Realistically, all RAM is a buffer pool. It's a read buffer for storage. Microsoft made an assumption a long time ago that working set data is going to be in RAM. So the more RAM, the more data you're retaining from disk before the data disappears and you have to go back to disk to go retrieve it. So the assumption that Microsoft made is that memory is faster than storage. Therefore, we will use RAM to go do this. What if, and this is a big what if, what if the memory that you have is good enough? What if you don't need more? What if the storage underneath is fast enough to insulate you from most of these burst operations that just flush all the data out and go drop down to disk? This is actually with the on-prem virtualization, memory density makes limits to virtual machine density that you've got. Most of the time, the storage is fast enough where the DBAs might not need all the RAM that we give it. And I'm guilty of this. I want all the RAM so I don't have to worry about disk. But in the cloud, what if premium SSD storage might offset the associated price with the memory footprint of the VMs to the point where the storage performance characteristics of your SQL Server stay the same, your license footprint goes down, your speed either stays the same or goes up. If you look at this example right here, it's the memory, not the core count, that is the differentiator on price. I mean, look at this. 4 cores, 28 gigs of RAM, $485 a month. 4 cores, 56 gigs of RAM. It's double, or almost double. Now, this is not with the SQL Server licensing footprint that's based off of the core count. So what if I were to do 4 cores and 28 gigs of RAM and then go with premium storage to get much greater latency, or excuse me, much lower latency, equally as fast of performance in terms of IOPS from the storage? You might actually be surprised that your storage is going to insulate you from the lack of RAM and you'd be fine. It's up to you and your workload to go figure that out. But the cool thing is, with Perfmon, you've got the data. So buffer cache hit ratio, page life expectancy, you start hitting some DMVs, you got memory grants pending, you've got your different wait stats, all of these different components. Don't just use one to say you need more RAM or not, but take a really good look. You might be surprised. If you can do this properly, you may be able to cut down the memory footprint, keep the speed, the performance of the machine the same or better, and save money. Now, regarding storage, to me, IOPS it's more relevant in the cloud than it is on-prem, but an IOP is just an IO per second demand on disk. Latency to me is what matters. How fast or how lack of fast, how quick can I get to storage and back with a given transaction that I either want to commit to disk or retrieve that block of data? So premium or ultra storage in the cloud, fast as possible. IOPS are critical in that there is a cap to performance by virtual disk and by VM, and you have to be aware of this. Block size times IOPS just equals throughput. So it always goes back. What are you actually consuming on-prem? Because if the thing that you're going to deploy into in the cloud has an IOPS or throughput limit greater, or excuse me, lower than what you're actually pulling on-prem, it's an immediate bottleneck. Is the bottleneck bad enough to where it would get in the way of overall performance? You got to be careful with this. The VMs have limits. If you notice on these two particular VMs, you get 16 data disks or 32, 12,800 max IOPS, 25,600 max IOPS. So if I only need 4 CPUs, but I've got 20,000 IOPS worth of demand, there's an immediate bottleneck on the smaller VM. You'd have to take care to actually go figure out, is the lack of storage speed going to impact my process performance? If it is, you may need to actually pay for the bigger VM just to get a greater IOPS cap. Or look for a different tier. Maybe instead of the DS 13 or 12 series, maybe you'd be looking at a D series or an H series, something that's more optimized for disk. So keep in mind those particular things are not the most intuitive. Perfmon has this information. Physical disk reads per second or writes per second will give you IOPS, and it's just like a fingerprint, and you can do it by drive. So you can figure out, how do I go slice and dice my workloads? Now, by the individual tiers like Azure SQL DB or Managed Instance, you may not have throughput, but you do have IOPS. So weigh this information very carefully and figure out if your storage demand is higher than what you're deploying into. And if so, is it acceptable? Sometimes it is. You'd be surprised. Same here. You can see if I want to deploy a 512 gig disk, managed disk, from this screenshot, you get 2300 IOPS or 150 megabytes a second. Is that good enough? If I need more speed, but not necessarily more capacity, do I need to deploy a bigger disk just to get the added speed? Or can I use in a VM only things like Windows storage spaces? Put together multiple smaller disks, group them together to save money, equal the speed or exceed the speed. So your mileage may vary on any of these, but it's worth tinkering with. Now, it's not just SQL Server. So Azure SQL Database also works for Postgres, MySQL, and Maria. If you're playing with anything NoSQL, Cosmos DB is phenomenal. We actually use it as a way to ingest a lot of different performance information from different machines. 10 millisecond at the 95th percentile max on reads and writes. I mean, it's stellar. There's Azure Data Lake, there's data factories for integration. So it's not just SQL Server, even though I know that's where our minds automatically jump to. If you haven't played with these, play with them, explore them. There's no harm in it. Spin up something in the cloud. I mean, even Cosmos DB just announced a free tier. It's 400 request units per second and 5 gigabytes of data, which is kind of a lot if you're just tinkering around. Completely free, works great. So,
There's one question before the
yeah, go
recap.
for it.
So, is RAM being less important due to the speed of storage being fast enough? Is it conceptual or is there data behind it? With a follow-up comment that without a rewrite of the storage engine, even with really fast storage, buffer pool is still going to act as your middleman. So
Oh,
relying
yeah.
on disk is additional code and operations to get to buffer pool and then to write to storage, and it adds up, is what he's saying.
Oh, no, it definitely adds up. The question is, are we talking a 5 millisecond runtime difference on if you've got double the buffer pool or not? Or is it, a 20-second performance difference with them? It's up to you and your workload to really determine that. But what I have found in most environments is that I can get away with about a 20-25% net reduction in buffer pool RAM and nobody even notices. I'm not saying get rid of 90% of the memory in there. You still have to have it. It's for working set data, but a small reduction in most environments is usually unnoticeable, and that small reduction might be enough to get you to the next lower tier on one of the cloud services and save some cash. And the math and the metrics to prove it, it's very situational based on your environment, but it's literally you take a workload with a reproducible workload, some scripts, distributed replay, however you want to do it. Get the data out there, run it on tier X, reduce the tier a little bit, replay the exact same workload, let the buffer pool warm up appropriately, and then replay it. Make it a true apples to apples comparison. You might be surprised at the fact that, yeah, we need RAM, but do we need a terabyte of RAM when we can get away with 768 gigs? Or do I need 64 gigs of RAM when 32 is going to be good enough? And you might be surprised. But again, use your testing metrics to go determine this.
Okay, thanks. There was a follow-up comment from another person saying that in that person's specific case, premium disk wasn't enough and had to increase the SKU to get enough RAM.
Okay.
But
That, as long as you've got the metrics and the proof to go validate that, that's all you need. I don't want to see people making assumptions without the evidence to back it up. If they've got a demonstrable need for more RAM, by all means, use what you need. Just treat it like the IRS. Use what you need, nothing more.
all right, thank you.
Cool. Okay. So to recap, you have to pick the resource allocation. You have to pick the platform that you want to migrate to, and be careful with that. Saving the company money. I take a little bit different twist on cloud stuff. Saving the company money is one of my biggest bottom lines with this stuff. Because I mean, the normal techie side, how to get the data there, how to manage it when it's there, that's fine. We can do that. But understanding the financial side to the business is something that will make you stand out in a very positive way if you can demonstrate that you've gone out of your way to help them save cash. And normally that does result in pay raises, extra training opportunities, extra days off. They really do appreciate this. And coming from a business owner here, I would love it if I saw this out of folks that we work with. You've got tons of platform choices, database as a service, instance, VMs, or staying on-prem. There's a lot of options there. There's really good choices, and there's a lot of really good platforms out there depending on your use case. Don't limit yourself to preconceived notions about these things. If the time is right to move to the cloud, pick what you need. It does work. With SQL Server anyway, pay by allocation, play around with the serverless option that's out there, allocate what you need, demonstrate what you need because people can't argue with the fact. Leave enough to have room for growth so you don't have to take stuff down and constantly grow this thing. Scale it as needed, and you would be pleasantly surprised at just how well these things actually work. So, are there any other questions or thoughts or anything you'd like to see as a follow-up presentation that I could work on?
First question is in. I'm going to vamp to get additional questions, but here's the first one. Why do cloud providers not do these sorts of calculations for you and give you recommendations on, hey, maybe you should scale this down?
That's a loaded question. Um, Microsoft is starting to. The problem is Microsoft can't tell if you've got something sized at, let's say, an 8 vCore managed instance, because once a quarter, you've got 50 people pounding on end of quarter reports, but the remainder of the quarter, it's quiet. Or they can't say that a lot of these usage patterns aren't holding back your processes, because then that would mean they would have to start getting to know your specific workload and really cross some lines with how things are being monitored and managed. Um, there are some companies out there with a lot of tools that claim to do this. The vast majority of them are not application aware, meaning they don't have the knowledge of SQL Server. So they don't do a good job with it. Even on-prem tools like, not to pick on any, but vRealize Operations Manager, Turbonomics, a lot of these things, they don't understand the SQL Server memory footprint. So they just go based on what Windows is telling them. Well, SQL Server hides what it's doing from the operating system for just about everything that it does. So a lot of times, I saw one just a couple of weeks ago. Database server had a terabyte and a half of RAM. One of those tools was telling the organization that they only needed 8 gigs of RAM on the machine.
Ah,
We got in, and on a terabyte and a half of RAM with SQL Server buffer pool at 1.45 terabytes, I'm not exaggerating, their PLE was less than 2,000 across a normal day. So they were actively using every bit of RAM that they had on there. But these other tools, they don't know. They're not application aware, and they make a lot of really bad approximations or um, assumptions that are just incorrect. So I think Microsoft is playing it safe and not going there, but I think a lot of these other companies aren't doing it right. Use a DBA, SQL Server. It's at least at this point in time, it's up to you.
yeah, that's reasonable. There are also Azure Advisor recommendations that can sometimes help with cost.
Can is the key word there.
True.
You
Very
just got
true.
to be careful. You just got to. To me, it's know your workload. Do you have the ability to replay what you would consider a production workload and gauge the effectiveness of a given set of resources and be able to put it on a performance scale? At what point do we consider this too slow? It's that's really the tricky part there. It's up to you.
Okay. Next question. For managed instances, what does no server level functionality mean specifically? Is that no logins, no login triggers, server level DDL triggers, instance level permissions like view server state?
It's kind of in the middle there. Where I was going with that is no RDP into the Windows layer, no XP command shell. Um, there are a handful of things like not being able to specify a drive or folder structure for splitting out data files and log placement, things like that. The vast majority of the instance level constructs that you just mentioned are there. I'd have to get specific on what is or isn't there, but from the top of my head, I think everything you talked through there would be there.
I think so too. That I didn't see anything that just struck me as no managed instances does not have that.
Yeah, I mean it's 99.9%, arbitrary number. It's almost complete.
All right, let's see if there are any additional questions coming up from anybody. This is probably where I, as a host, probably should have come up with a question that I'd be able to.
That's okay.
SP send DB mail. No, I'm pretty sure that one's not there.
Um, that's a good question. Manage instance SP send DB mail. Um, no, it's there.
Oh,
That's funny.
sorry, Anders, you lose this round.
No, it is there. You have to. Yeah, that's hilarious. It's there.
All right. So I think that's all the questions that we have. Actually, he's saying that they took it out for a while, but it must be back now. So
Okay, cool.
I'll give you half credit, Anders.
Yeah, no, that brings up a really good point. The cloud and all of its services are changing so quickly. It is really tough to keep up with this stuff. I've seen multiple people where they get up to go do a presentation at SQL Saturday or even past Summit, and they pull up the management interface morning of, and everything's changed. You got to be on your toes with this stuff. It's hard to keep up, but you don't have to constantly deal with the latest and greatest. I mean, it's good to have it, but use what you need. Be careful with it. Cool. Well, I would say if you all have any topics that you want to see in greater depth, let me know. I'm happy to put together a session for you all for a coming month whenever there's an opening, and come back and present for you.
Awesome. It looks like one last question got snuck in under the wire.
hmm
For external processes, would you recommend kicking off PowerShell scripts or using VMs?
What kind of external processes? Because if it's an external PowerShell process that is just a script to go do things, then definitely, yeah, an Azure Runbook would be a perfect example for that. If it's something that's calling executables that a runbook or the app engine really won't handle, then you may be stuck doing that in VMs.
So yeah, the clarification there is EDI style work, like business to business sending information interchange.
Um, Depends on your process, honestly. Standard DBA answer, it depends. Um, but if the process is such that it works with PowerShell in kind of a standalone manner, and you don't need a lot of these external dependencies, try it in a runbook. If it works there, by all means get it there, because then you don't have to worry about an OS and all that jazz. If there are known problems with that process, you may be stuck putting it in a VM. But I would claim at this point, if you have any amount of time to take that process and try to modernize it so it would work with just standalone PowerShell and a runbook, do it that way.
Yeah, another option I could throw out is Azure Functions if it's C sharp, F sharp, Python, Go, like about a
Yeah,
half dozen languages. So if you
yeah,
can rewrite it as a function, that might also work for you.
yeah. The one of the challenges with the cloud, it's kind of like walking into Walmart going, I want cereal. You've got like 14 aisles of nothing but sugary cereals. So what works best? There's a lot of options.
True.
But you may have some limitations with those processes. Functions would be great. Again, you pay by the consumption rates and not the allocation at that point. You pay by execution and the runtime of it. And that's a great model to go in because that'd save you a lot of cash.
Let's see. Our single DB, so would Azure SQL Database and Managed Instance, do they have the same code base? Like for functionality that exists in both of them, does it behave the same way or are there differences?
Ooh, that's a hard question because the SQL Server engine itself is identical. It's the same engine that you get on prem. The hardest part there is that from a T-SQL standpoint, unless there's a limitation with calling, cross database calls or things like that. If it's just regular T-SQL, it'll work identically. If you're with the code calling something that the database as a service doesn't offer, of course, it's not going to work. Um, do you have examples you're thinking of there? Because there's really not that many differences in just core code.
Yeah, we'll see if there are any specific examples.
Yeah, I mean, there's things like a lot of the instance level DMVs with SQL DB don't work. That layer of things, not that big of a deal though. Usually we don't have to worry about those.
Right, and I'm parsing this as if you have the functionality in both. Okay, let's see. In
Yeah.
regards to functionality now being cloud first versus on-prem. Okay,
That brings up a good point. Um, Azure SQL DB seems to be where they're introducing the new features first. Um, in terms of box product versus managed instance, I personally haven't seen a feature make it in a managed instance before it goes into the box product, but at the same time, I am admittedly not really looking as much for the development features at this point with just the nature of what we do. So if they very could well slip in, new functionality or new commands or changes to behavior with the managed instance before it comes into the box product. I personally wouldn't expect them to be in sync either. So you may get something net new in SQL DB that isn't in any of the other stuff. And if you encounter that, let me know because I'm curious. And it also means you're on the cutting edge and bleeding edge. And I really want to talk to you because that's just fun to nerd out on.
all right, I think that might be all of the questions.
Cool. Well, hey, if anybody here thinks of anything net new, or anything else down the road, let me know. Happy to help. And again, if there's any other session you want me to present on, happy to do so.
Fantastic. I will ask people because they may not be forthcoming right now, percolating, I'll say.
Yeah, no, I always take a lot of time to think about that kind of stuff.
But yeah, definitely would love to have you back at some point.
Awesome. Cool. Thanks,
All right.
everybody.
Thank you very much. Assume that everybody's just standing up at their desks clapping, giving you a standing ovation. I'm
I'll take it.
sure that's what's happening right now. All right. Thank you, everybody. Thank you, David. We are going to say good night for tonight. But before that, I have to promote SQL Saturday Raleigh one more time. So, again, April 18th, Morrisville, SQLSaturday.com/981. Come check us out. And with that, we're going to wrap up the stream for this evening. Thanks everybody for attending. Sorry we couldn't do it in person, but things got a little tricky in terms of, oh, we'll call it logistics. Hand washing logistics is how I'll phrase it.
I
So
like.
so next week, hopefully, we're going to be able to do it in person, but I will give an update on the meetup when that happens. Worst case scenario, we'll still do an online meeting. So see you all next week, hopefully. Have a great night, everybody.